Distributed application. Remoting is an infrastructure that allows a developer to use remote objects. Remote objects are objects that are based or instantiated outside of the caller's application domain. This example shows you how to use both remote objects access mechanisms, pass-by values and pass-by reference. It also shows you the power of remoting for distributed computing with a simple yet powerful implementation of a task server. Basic remoting. Remoting is the capability to communicate with components in separate app domains. Figure shows a simplified view of two objects communicating via remoting. A client component in app domain A communicates with a server component in app domain B. An app domain is an execution environment within a process. It separates managed applications during execution. This provides several benefits including reliability and security. Remoting supports multi-tiered as well as distributed architectures. The server component in app domain B could easily be extended to a client role communicating with a server component in another app domain. Furthermore, a remote component could be located in another process on either the same or a different machine. When a component is set up, the underlying plumbing required to maintain remote communications is hidden by the remoting architecture. There is a server, which is a DLL that must be hosted by another application, either IIS or a custom host that you built. There is also a client, which is an executable that makes an outer process call to communicate with the remoting server. Now we shall see how to build the remoting server first, and then the client, and finally a couple of ways to host the server. After the server is hosted, the host begins to run. Remoting server. A remoting server object is just a class that derives from Marshall by reference object. The basic server class inherits Marshall by reference object, which supports the basic functionality for a callable component over the remoting architecture. This class is implemented as a DLL, negating the need for a main method. The only method in this class is the getServerResponse method, keeping things simple. Each remoted component requires a configuration file named web.config to specify necessary operating parameters. Remoting client. Writing a remoting client is just a little more involved than writing a remoting server. Writing a client requires finding out the type and location of the remote server object, initializing configuration from a file, and creating an instance of the remote object with the type and location information obtained earlier. The system.runtime.remoting namespace contains all the basic remoting classes. Our remote server component that will be instantiated and called is in the basic server namespace. Within the main method, the type of the basic remoting server class is obtained with the type of operator and stored in a type object. Next, the URL of the basic remoting server. Remoting setup. There are two ways to get a remoting application up and running: via a web server or a host utility. Use Microsoft Internet Information Services (IIS) as a web server to host the remote server component. Web server setup. Demonstrating the host utility requires code for a new client and server program and the utility. The following steps show how to set up a remote server component via the IIS web server. Before actually starting the procedure, work out a directory structure so that it will be easy to follow along. Here's what your directory structure should look like. Compile the server component from the basic server directory with the following command line. Open Internet Information Services (IIS). The following steps work for Windows XP but are different for other operating systems. For example, WinNT, Win2K, Win2003, Win2008, and Vista are all different. If the actions don't match your OS exactly, consult your documentation to accomplish the same tasks. Expand the server node under which you want to create a virtual directory and right-click Default Website. From the menu, select New Virtual Directory. This opens Virtual Directory Creation Wizard. Click Next. In the text box for an alias, type in any meaningful name for the virtual directory, such as Basic Server Demo. Click Next. In the text box for the physical path that the virtual directory will refer to, enter the open tag path close tag / basic server directory, where open tag path close tag is the actual directory you specified in step 1. Click Next. There are several access permissions from which to choose. The read and run scripts such as ASP options are already checked, and that's fine. Accept the defaults, click Next, and then click Finish on the last screen. IIS will use the web.config files in the basic server directory when it loads the server component. The remote server component is now set up. Use the following command line to compile the remoting client program from csc /basic server /basic server.dll basic client.cs optionally. Remember to add a reference to the basic server project. Right-click the References folder in Basic Client, select Add Reference, click the Projects tab, select the basic server project, and click the OK button. You'll also need to add a using declaration for the basic server namespace. Finally, run the basic client.exe program in the basic client folder to test the system out. If all goes well, the following output will be printed to the console. Host utility setup. The following example illustrates host utility setup. Replace the basic server with hosted server and the basic client with the hosted client directory names. The host utility setup method uses a program that configures the remote server component. The process isn't necessarily easier or harder than the web server setup method. Channels marshal, format, and transmit messages across app domains. Each of a channel's tasks opens new opportunities for extensibility. For example, message contents can be marshaled to conform to the proper data representation using custom syncs. The message itself can be formatted via the built-in Sample Object Access Protocol SOAP or binary formatters. In addition, transport protocols such as HTTP or TCP, which are built-in, can be configured with ease. The architecture also supports customizable marshalling, formatting, and transmission components that can be plugged in as needed. The HTTP channel linking the proxy in app domain A to the stub in app domain B is a built-in channel component supporting default marshalling, XML/SOAP formatting, and HTTP protocol transmission. Lifetime management. A remote server component exists for a default amount of time and then makes itself available for garbage collection. It's often more desirable to explicitly manage the lifetime of remote components. This is why the remoting framework provides a leasing mechanism for finer granularity of control in remote component lifetime management. Remote leasing operates via a collaborative protocol between one or more client components, a server component, and a lease manager. Remote server components begin life with a designated amount of time before garbage collection. Client components register with the server component's lease manager for notification of when the server's lifetime is expiring. The lease manager keeps track of server components and notifies clients of when the server will expire. When a server has reached its expiration time, the lease manager notifies the client and waits for a designated amount of time for a reply from the client. If the client wants the server to remain alive, it returns the amount of time the server can live to the lease manager. If the designated reply time from the client to the lease renewal query expires, the lease manager marks the server object for garbage collection.